Alright, for number 1, you needed to translate this. 5 times the difference of a number and 3 is 17. So 5 times x minus 3 in parentheses equals 17. Your x, it doesn't have to be x, it could be whatever variable you want. But because 5 is being multiplied to the difference of, 5 needs to be multiplied to everything. It can't just be to the x, to the 3. Number 2, you need to find the range. So you're looking at all of your y values. What is your lowest y value to what is your highest y value? So because this keeps going down and keeps going up, your range for this would be all real numbers, and it can be written one of these 2 ways. First one is set builder notation. The other one is interval notation. But they both mean from negative infinity to positive infinity, or all of your y values. Number 3, you needed to solve this system of equations. I know that was a couple units ago. And there are different ways you could have done this. Graphing is not on here, but I'll show that here in a second. So for substitution, you would need to get one of the equations where it's just x or just y. Here I chose to get just x. And then you would take that equation, put it into the other one, and start solving. Get one of those answers. These weren't supposed to be fractions, but they ended up that way. And then put that back into the other to find your missing value. Or you could have done elimination. There are different ways you could have done that. I just looked at it as if I multiplied my first equation by 2, now my y values both have the same coefficient. To eliminate them, we could add the 2 equations together and then start solving. And then the rest of that process is the same. If you did this in Desmos, or on a calculator, either or, and then found your intersection point, it would give you a bunch of decimals, so you would have to convert these decimals to fractions, but they would be the same fractions that were up there before. Questions on 1 through 3? Number 4, you need to solve this to get y by itself. So add 5x to both sides, divide everything by -1, and you would get y equals -5x minus 1. And then for the last one, you needed to solve this. So distribute on both sides, combine your like terms on both sides, and then pick what you want to move and start moving that and the opposite, and divide. And you should get x equals -9 no matter how you solve that. Questions on those 2? Right. So today we're going to continue our factoring notes. The class before last, we were talking about factoring by GCFs. What we do today is going to build on that. So everyone should have notes in front of them that look like this. And then Michaela will come back to you. So there are not many examples on this because really, it's the same thing as we were doing before, just a little bit differently. So when we were factoring out a GCF, we had 2 terms or we had 3 terms. When we factor by grouping, we'll have 4 terms. So 4 terms, grouping, in your mind, connect those 2. The very first thing we're going to do is when you see 4 terms, we're going to split them down the middle. So I'm just going to draw a little line down this middle so that the first 2 terms and the second 2 terms are separated. When you draw that line, make sure whatever this sign is, plus or minus, stays with that term. Then we're going to just look at the first 2, and we're going to see what could we factor out, what GCF could we factor out. Remember, that's the highest number we could divide out of both, and then the smallest number of variables we could divide out of both. So what could we divide out of both of these things? What do they have in common?
What do they have in common?
These first 2 terms.
They both have exponents.
They both have exponents. They both have an x. So we need to figure out how many x's can we take out of both. Alex? Say that one more time. Like the number 1 or 1x? Yes, number-wise, we could only take out the number 1, but variable-wise, we could take out x's. We just need to figure out how many. Willow? 2. Because I can't take out 3 because this one doesn't have 3. So then I would be dividing both of those terms by x squared. Remember, when you divide exponents, you're really dividing variables, you're really subtracting the exponents. So when we divide these, what's left? X plus 7. You've had 3, you divided 2 out, only 1 is left. For the 7x squared, you divided out all of the x's and just 7 is left. Then same thing for the last 2. What could we divide out of positive 2x and positive 14? Alex? 2. Whatever the sign is here, that's what sign you're going to put here. So I could put plus 2. That's why it's important to keep the sign with it. And then if I were to divide both of these by positive 2, what's left? X plus 7. Once you do that, you're going to take whatever we put outside, so that would be our x squared and our plus 2. We're going to group this together in one set of our factors. And then when you look at the others, we see that we have the same thing twice. We're not going to write it twice. We're only going to write it once. You can think about this like doing a range when you have a list of numbers. If you have multiple 5s, you're not going to write 5 multiple times. You're just going to put it once. So then our second factor would be whatever this is, but we're only writing it once. When you're factoring by grouping, whatever's inside should match. If it doesn't match, something's off there. And then that would be your final answer. This very last step is to check yourself, to go back and see, does this work? Did I do this correctly? So if I were to rewrite what we just have, or just got, x squared plus 2, x plus 7. And then I go back and I distribute it back out. So I take x squared and I multiply it to x and 7. Remember, when you multiply variables that are the same, you're adding the exponents. So this would give us x to the third, and then plus 7x squared. And then I'm going to do the same thing for the other one. Take 2 and multiply it to x into 7. And when I do that, we have 2x plus 14. And if we look back at the original, those should match. So we did this correctly. Before we continue on some other examples, do we have any questions so far? Can you see from right there? All right. Does anyone still need this before I scroll down?
Okay.
We're just going to do some of these together, then I'm going to let you try the others. Starting with number 1. Go back, split it down the middle. After the second term. And then we need to find what is the GCF of these first two. What number can I divide out? Can I divide out any variables and how many?
You can divide 3 by both.
Yes.
And for variable 2.
2x
So
squared.
that's on both sides.
Okay. So I wrote it like this, dividing it just to remind us of what we're doing. If you need that, do that, and you can continue writing that. But if you don't need that, you don't need to write it. So if we divide both of those terms by 3x squared, what's left? X plus 5. And then what could we divide out of the last two? 2. But because this one is negative, we're going to make this negative 2. If I divide negative 2 out of both, what would be left? It would be positive 5, and the first one? X. So our insides match. Had we factored out a positive 2, we'd have negative x minus 5 instead of x plus 5 like we need. So then our two factors, the outside terms, 3x squared minus 2. And then the inside terms, but we're just going to put that once. Any questions on that one? Brings you number 4. Yes, Josh.
Okay, so after the 3x2 and parentheses x plus 5, yeah, after that, how'd you get the one below that?
So the outside terms make 1.
Okay.
And then even though there's 2 of these, we only write them once. So if these are the same, we can write that this is one of the factors.
Oh, so usually they're going to match up?
They should match up, yes.
Okay.
All right, number 4. If I split this down the middle, when I'm looking at the first two, What could we divide out of those two?
Oh. You can do -3 on both. -3 on the x.
Okay, so 3 x's is what
Yeah.
you're saying. So x to the third. So if we're dividing both of those by x to the third, what's left?
X and then
X plus 4. Okay. And then for the second set, what could we divide out of both of those?
2.
2. And it'll be positive 2. And if I divided both of these by positive 2, what's left?
X and 4.
X plus 4. So what would our two factors be?
X3. It'd be 2x3, right?
X to the third plus 2.
Ooh.
And then x plus 4. So it looks complex because there's a whole lot of numbers and variables and exponents, but it's really the same thing we were doing before, just double now. Let's do number 8, and then we'll do one on the back, and then I'll let you guys try some. For number 8, what could we divide out of the first two?
Okay.
2, yeah.
You can do. You wanna go?
Well, you guys can, it's not a one-person thing. Everyone can join in. 2, yes.
1x
Yes.
and 1y.
Yes. So if we divide both of those by 2xy, what's left?
1x and 3.
1x, 1, and positive 3. Now, the second set of numbers, what could we divide out of that?
Nothing.
-1. So you can always divide out 1 or -1. In this case, because it's negative, we would divide out a -1. And then if we divide out a -1, what's left? In this case, if we just divided out 1, it would not change. And then we have -x minus 3, and that's not what we want. What would our two factors be?
2xy.
-1. And x plus 3. Okay, questions so far? Once you have this, go ahead and turn it over to the back or do one of those, and then you guys will have time to practice. We'll do number 10. These don't have any numbers, but they do have common variables. So what could we divide out of the first two? A squared. And if we're dividing a squared out of both of those, what's left? A, and then I heard plus, but not the second one, B. And then what could we divide out of the second two? This B plus B, yep. And if we divide B out of both of those, A plus B. We can like almost assume what that second part should be, but we also don't want to assume because we want to make sure that's what we actually get. All right, and then our two factors. A squared plus b and a plus b. Beautiful. Okay. So you have the remaining problems that we did not go through on this, as well as there's a practice page full of these after you get through these. Do all of the ones on this page first, so up through 12, and then after that, try, some of the ones on the practice page. Does anyone have any questions on what we're doing for the remainder of class? You guys have this time to work.